Hello there. This lesson is for geometry. How can we prove triangles are similar? Also called similar triangle proofs or similarity proofs. Okay, now I'm going to start off very easy with number one. To prove two triangles are similar, all we need is two angles of one congruent to two angles of another. That's angle similarity, much less than we have to do when we do congruent triangle proofs. So we're going to write either angle similarity or AA is congruent to AA. Now remember, when two angles of one triangle are congruent to two angles of another triangle, then the third angles have to be congruent anyway, because angles have to add up to 180 in a triangle. So if you had one was 100 and one was 50, and then the other triangle, one's 100 and one is 50, they're each 150 so far. So the third angles would have to be 30 in each. So then all the angles would be the same. And for two triangles to be similar, that's all you need. Now remember, similar triangles are different than congruent triangles. Similar triangles are the same shape and not necessarily the same size. Okay, congruent triangles are the same size and the same shape. So we write the givens. Angle BAC is congruent to angle EDC, given BAC, EDC. And then I could say angle 1 is congruent to angle 2 because vertical angles are congruent. And that's all we need to have two triangles congruent. We have one angle, we have two angles, okay? So basically I can say triangle ABC is similar to triangle DEC because of angle similarity. Okay, now I'm going to go a little further now in the next ones. Actually, so I'll do one more like this before we do the next one. Which one seems more challenging? Hold on. Oh, I can do number 2. Statements, reasons. Angle RSO is congruent to angle LNY. Angle ARS is congruent to angle BLN. And those are given. Okay? RSO to LNY and ARS to BLN. I'm going to put a little 1 and 2 here. Angle 1 is supplementary to angle ARS, and angle 2 is supplementary to angle BLN. How come? Because linear pairs are supplementary. Linear pairs are supplementary. Okay, now I can say that angle 1 is congruent to angle 2 because supplements of congruent angles are congruent. Okay. Now I actually have enough information. I have angle there, angle there. The other angles outside the triangles, these angles didn't count, they were outside. And now I can say triangle ROS is similar to triangle LYN because of angle similarity. Okay, so we just did another one. Now, without doing number 3, I'm not going to go through it. I'll just talk about it for a second. LA is parallel to DR. Okay, so now, and this angle here, angle E, is congruent to itself. And then I can say angle 1 is congruent to angle 2 because if 2 parallel lines are cut by a transversal, then the corresponding angles are congruent. Okay. Now, but that's all I'm going to do with that for now. Then that's all you need to prove the 2 triangles similar. Now I'm going to do 2 more the second way. I'm actually going to just change the question a little bit. We do this on day 2, but I decided I want to put it on day 1. On day 2, we're going to do 2 other ways to prove 2 triangles similar. But over here, where it says to prove this, so this is different. We're not just proving the triangle similar. It wants us to prove this proportion. But the way that we would ask the question probably on the test is actually to say, prove that DE times BC is equal to AB times EF. So if you're asked to prove this, then what you're going to do is you're going to put a proportion and you're going to make sure that, right, DE times BC, they have to be diagonally across from each other, and AB times EF. So that's what's here, and you're getting it. If I was given this first and you had to come up with the proportion, you see after you have to come up with it, these have to be diagonally across from each other. These, because when you cross multiply, you're doing that times that. So that's how you have to make sure you put them in. People mess this up on the test all the time. So if you saw this, first you would have to do this. Okay? So this would be first, and this would be second. Okay? Or this would be the last step. This would be the second to last step. So statements, reasons. I'm just going to do 2 more proofs, and then I'm calling it. So write the givens. Angle BCA is congruent to angle EFD. Given. 2. AB is perpendicular to BC. DE is perpendicular to EF. Given. So angle BCA is congruent to angle EFD. Put those in. AB is perpendicular to BC. DE is perpendicular to EF. So angle B and angle E are right angles. By the way, I could have put this as step 2 given and then step 3 given. I don't know why I just put them together. It does not matter. Some people put all the givens together as one thing. Okay? No, I believe that you're normally used to me doing it as separate steps. So why don't we just do that? So that's 3, 2 is given, and 3 is given. Again, it doesn't really matter as long as you have all the givens. That would be 4, and that would be 4. Angle B and angle E are right angles because perpendicular lines form right angles. perpendicular lines form right angles. Okay? And then we can say that angle B is congruent to angle E because all right angles are congruent. Now I have two angles of one congruent to two angles of another. So I can say that triangle DEF is similar to triangle ABC because angle-angle similarity. Okay, now two more steps. I'm going to say that DE is to AB as EF is to BC. Hold on one second. The reason being, corresponding sides of similar triangles are in proportion. And then lastly, I can say DE times BC is equal to AB times EF, because in a proportion, the product of the means equals the product of the extremes. In a proportion, the product of the means equals the product of the extremes. So that was doing a proof at a new level. Okay. Now, what are the means and the extremes? Oh, right. The means, like if you're reading the New York Times, it goes down in columns. The means are the middle ones. A, B, and EF, here are the means. And the DE and BC are the first and the last ones you would read if you were reading in columns. Those are the extremes. So in a proportion, the product of the means is equal to the product of the extremes. Okay? It just, in other words, you're allowed to cross multiply. That's what it means. You're allowed to cross multiply. Okay. And I'm going to do one more, and then you're going to have to finish the rest. Okay? Number 5. But I'm adding on, okay, well, we have angle 1 is congruent to angle 3. Angle 2 is congruent to angle 3. And those are given. Okay. So now, and we want to prove this, but I'm going to say instead of proving this, let's just assume they actually, because on the test it would be more like that, they want us to prove that AC times ED is equal to CD times AB. So they actually want us to prove this, but we have to prove this before we can prove this. Okay? So you're going to prove the two triangles similar. But now look, if angle 3 is congruent to angle 1, and angle 3 is, if angle 1 is congruent to angle 3, and angle 2 is congruent to angle 3, then angle 1 must be congruent to angle 2. Now, that's called the transitive property, but you can also call it substitution, because if I substitute the, like here, like if I put angle 2 over here where angle 3 is, since they're congruent, I'll get angle 1 is congruent to angle 2. So I'm going to call it substitution. Okay. Now, what else do we have? We have a freebie. We have vertical angles. Angle 4 is congruent to angle 5. vertical angles are congruent. And then what else? Well, now we have enough to prove the two triangles similar because we have the 1 and 2 are inside and the 4 and 5 are inside. Now I can say triangle ABC is similar to triangle DEC. Goes for angle, angle, similarity. And then I have the two more steps. I can now do the proportion. Oh, I didn't say what it was before. I just wrote it. But if you have two triangles are similar, then the corresponding sides are in proportion. That was in yesterday's lesson. So if you make the proportion, you can say corresponding sides of similar triangles are in proportion. So once again, AC is to CD as AB is to ED. Corresponding sides.
Okay, I found this on the web for what's a CD is a...
Sorry, Siri thought I said her name. Corresponding sides of similar triangles are in proportion. And lastly, I have AC times ED is equal to CD. AC times ED is equal to CD times AB. And that is because in a proportion, the product of the means is equal to the product of the extremes. Okay, so now, just so you know, that when we do similarity day 2, we're going to know how to do the proofs part because those are we added on like this step to that sheet. But and then you're going to learn 2 more ways to do similar triangle to prove that two triangles are similar. But we're going to do it not necessarily in the same format for those other 2 ways. The angle one is going to be the ones we really do in the proof. Okay, I hope you have a good rest of the day. Goodbye.